So what I'm going to do is give you an Internet of Things demo, and I gave a little bit of this in my talk yesterday, and I'm going to give a talk a little later on this afternoon. But with this group, I'm going to show you a little bit more kind of under the covers of how I actually did this, and maybe answer some questions. But let me just set this up for you with kind of a sort of a hypothetical, and this is what I used in my presentation yesterday. Imagine that we are all working at a manufacturing company for refrigeration units, and here is our industrial automation, and here are robotic arms that are making these refrigeration units. And the great thing about this company is that all of you run manufacturing operations. I love working at this company with all of you guys because you run manufacturing beautifully, except for the little incident you had last week where one of the servo mechanisms in the robotic arm overheated. It acted really erratically and did about $1 million worth of damage. It was really bad. You had to shut down the whole production line. And I heard through the grapevine that you were called into the CEO's office and there was a lot of yelling there. Something about Wall Street really being upset about the lost earnings, something about an OSHA safety audit going on, and also something about someone losing the job if this ever happens again. So my question to all of you is, what are you going to do about this business problem? This is a business problem. Plus it's kind of a personal problem for you too, but setting that aside, it's a business problem. What are you going to do? Well, why don't you come on into my whiteboard and let's kind of conceptualize here about what we might do. Why don't we consider using the Internet of Things? What if what we did is we put a temperature sensor right near the robotic arm. We put a sensor there, and every second just measure the temperature. And then what we could do is then send that information up to an edge gateway and over to a power controller, and if the temperature ever exceeded a threshold, just turn it off. It's kind of really a simple idea. And so the whole simple idea is basically to measure the temperature. If it goes above a threshold, just turn the thing off. One of the things I also forgot to mention to you is that your connection to the internet from your factory kind of goes up and down a lot. It's not really that reliable. So yeah, you want to connect to the cloud, but maybe you don't want to fully depend upon the cloud in that situation. So let me give you a little bit more specific picture. This is the previous diagram was a conceptual diagram. This is more of a physical diagram. So what we actually have here is this really cool IoT controller that controls the power. This is this unit right here that I have the green light plugged in, and you can see, what am I going here? You can see that the power is on, the robot is running, and it's really very simple. There's a little power relay from this power controller, which is a Raspberry Pi, and I have a little algorithm running there. If the temperature gets hot, it just toggles the pin high, turns off the power, and stops the robotic arm. But one of the interesting things is that it's really running independent of the cloud. I also have a separate design using the cloud, but this one is independent of the cloud. So let's go actually see if this will work. So what we're going to need is a heat source, and I thought about bringing a hairdryer, but I thought, nah, that's kind of noisy. Who wants to bring a hairdryer? So I brought a nightlight, an incandescent nightlight. It's actually getting harder and harder to find incandescent bulbs, but that's a different story. So what I'm going to do is, if I look at the temperature, I'll show this to you, but I don't usually do this in my demo, but I'm going to give you more information. These are little terminal windows into the system, and what you can, I don't know if you can see here, it's running at 29.53 degrees Celsius, so it's running kind of warm in here, 29 degrees, and my threshold, I actually changed the code so that it's going to trigger at 30 degrees, so I have a feeling if this works, as soon as I put this thing down there, it's going to turn this thing off. So the idea is that when the temperature goes above 30, this controller will detect it, turn that robot off. Let's see if it actually works. There you go. And when the temperature goes down again, it should go back on again. So it's really very simple. It goes off, it goes back on. So let me tell you what's actually happening, what made this work. It's a simple demo, and you say, wow, that's kind of interesting. But what's interesting to me is how this was all set up. This is actually using Amazon Web Services, and so let me show you how I actually configured this. So I go into my console, And in AWS, what you set up are what's called green grass groups. And in the green grass group, for some reason my internet connection just went down. Just bear with me. Oh, there it goes. I don't know what happened there. So what you do with the way that you set this up is you have a Raspberry controller, Raspberry Pi that controls the power. I have what's called a green grass core, which is basically AWS software that's running at an edge. You would typically run it like a gateway, or in this case, it's just running in a Raspberry Pi. And I have a publisher. So the publisher is my sensor. It's sending MQTT messages to the subscriber, which is the power controller. So it's just a pub sub, publish, subscriber messaging. That's all that's happening. And the green grass is what's making the messages go back and forth. What's interesting about this is it'll run independent of a wide area network connection. I needed the WAN to set it up. I need to set up these subscriptions, as you can see on the screen here. I need to tell the core that a publisher can talk to a subscriber over this MQTT topic. And then I had to deploy that down to the green grass core. So you set up a subscription, and then you deploy, and you can see on August 16th, I deployed it and was successfully deployed. So I needed the cloud to provision this and deploy it to the edge. But now that it's deployed, let's do this other experiment, and this is my wide area network board. Okay, so I just disconnected that. Let's see if this works. So now what's happening is the sensors are measuring the temperature, sending it to the controller, back and forth. There's no wide area network connection. And so that works. So what I just proved is you can deploy all of this to the edge and have it run autonomously. So I needed the cloud to do the provisioning. I needed the cloud to kind of set it all up. I needed the cloud to have my certificates pushed to all of my Internet of Things devices at the edge. But once I had that all set up, even if my cloud connection goes down or goes back up again, it still works. Now, let me tell you something. Now, why is this thing going off and on? This is kind of interesting. The reason it's going on and off is because this is really running very hot. It's running right at about 30 degrees. And so when I designed this and tested it in Massachusetts last week, it was very hot, very humid. The temperature was running really hot on these devices. I set my threshold at 38 degrees Celsius because it's about 33, 34 degrees Celsius at my home where I tested it. And then when I demonstrated the same demonstration in downstairs, it was so cold in that room, it was running at 27 degrees. I had to go and change my code to change it. So I lowered it way down to 30. And now look at what's happening. I'm out here, all these people are here, it's running really hot. Now it's running right by the threshold. So what is this really demonstrating? Let me turn this off because it's a little bit annoying. What this is really demonstrating is you can architect your Internet of Things. You can get it all tested, but what makes the Internet of Things different than just a regular IT project is that it depends upon the physical environment. Your physical environment can impact the way the system operates. And so this is just a very simple example, but just because it was more hot, more humid, maybe there's vibration, maybe there's moisture. So that's part of what makes the project a little bit more interesting, a little bit more difficult. So I wanted to just show you that. I wanted to show you kind of how this was all set up. One of the other things that I use quite a bit in my testing is setting up of rules and setting up of measuring and monitoring. So there are no messages actually being sent up to the cloud right now, but I can actually configure this for whatever topic is being used and actually monitor the messages and see the messages going back and forth. Let me plug my wide area network connection back in again. The other thing that I actually spent quite a bit of my time with, just to kind of share with you a little bit what I struggled with on this, partly was just getting all the connectivity working. Believe it or not, networking. I had an older device that was using Wi-Fi as my sensor. I finally got rid of the Wi-Fi. That was too unreliable. The device was too fragile. Finally, I discovered about the Sense Hat. So I did everything with Ethernet. Everything is wired. That made it more simple for me. The other thing I struggled with is all the certificates. There are certificates on all of these devices, and every endpoint can't talk to the green grass unless the certificates are there. I needed a cloud to actually deploy these certificates. So I spent quite a bit of time on certificate deployment, access control. I had to set up policies in AWS. What are the policies? Who can talk to who? I wasn't expecting all of that, but I spent quite a bit of time figuring that out. Actually, I had to have one of the AWS solution consultants work with me last week just to figure out the certificates because it wasn't quite working. So that was an area of struggle for me. But once I got all those things up and running, it kind of worked like magic, and then it's been working, knock on wood, reliably ever since I got here. So what I wanted to do is basically kind of set this up for you, show you the demonstration, and then answer any questions that you may have on terms of the certificates, in terms of the messaging, the networking, what I struggled with. Do you have any questions about any of this? Because I can even show you some of these devices. To tell you the truth, before a couple of months ago, I really didn't know anything about the Raspberry Pis, but they are fully functioning Linux systems. I can do a VNC terminal. I can, VNC right into these things. So this is my power controller. I have terminal sessions here, but I brought the connection down, so it's not able to connect. So it's not working right now. But I'm able to bring up a virtual network connection into the device and actually, use it as a regular system. So they're quite powerful. There's an awful lot of libraries, a lot of Python code, a lot of C libraries to really program all these general purpose I/O pins. So a lot of infrastructure is already there. It's a great testing environment. And the other thing that I'll say is that I sort of knew how it worked, or at least I thought that I knew how it worked. But it really took me actually making everything interconnected and struggling through it, and then I realized, oh, this is how it really works. And so what I'd recommend is, this equipment is really inexpensive. The Raspberry Pis are $35. Power connector is inexpensive, a micro SD card is really inexpensive. It's really easy to buy the equipment and play with this. And many of the cloud providers like AWS have a free tier. So without a lot of money, you can actually get involved and start playing with all of this and really learn. So that's all I really kind of formally wanted to show you. But let me answer any questions that you have. Go ahead.